So today we are honored and pleased to have Ludovic. Ludovic will be our professor for today. So for those who are new today, maybe just want to reiterate that the materials from our series will always be available on the Afredac platform. You can always check them after our sessions, and also to remind you that every other week we also have the R for Fun club sessions, whereby we try and brainstorm and troubleshoot any R problems or ideas that you have. You can be joining those sessions as well. We share, and also we try at least whatever is covered in this training session, we also try to recap it in that Art for Fun club session and try to iron out in case there's any issues. So hoping that the rest will join us along the way. Let me hand it over to Ludovic for today's session. Thanks so much, Ludovic. Over to you.
Okay. Thank you. Okay, so thank you so much for the introduction. And before I start with anything, I'd like to express my gratitude for this opportunity. I think 10 months ago, I started this journey as someone who was just interested with R. But as things stand right now, I think I'm a little bit motivated to learn more and more about R. So sharing the floor with my mentors, Dr. Duncan, Ashna, Frank, and the others, the amazing team at Afredac, I think it's a privilege for me, and I hope if you guys inspired me, maybe I can inspire others who are going to attend today. So our section today is titled Data Cleaning with dplyr package, transforming mess data into meaningful insight. And in this session, we are going to explore at least the first three agenda in this chart, in this slide. So we'll be covering introduction, why do we need to do data cleaning, and then we'll have an overview of the dplyr verbs, and then we'll practice on R. And then we'll have a little bit of conclusion, and then we'll always have a revision quiz at the Afredac platform. So maybe to start with the introduction, when I attended the course 10 months ago, it was fun to learn that most of the time with data analysis is usually spent on cleaning and make sure that your data set or data frame is ready for visualization or interpretation. And this may be because there are a lot of things that can come with the raw data set. So this may include things like inconsistencies in how the data was recorded. For instance, you may have Tanzania with a capital letter in one entry and Tanzania with a small letter in the other entry. And this, during analysis, may be interpreted as two distinct observations. And then we may also have some incomplete data, such as empty cells. We may have some duplicates. And then we may also have some mismatched units. For instance, we may have some numbers stored, maybe heights, stored in centimeters and others stored in meters, which will make our analysis to become impractical. But we may also have some other numbers stored as text. So as data analysts, we need to spend a lot of time trying to clean all of this before we proceed to visualization and try to find the story out of our data set. And then sometimes we may also have some invalid entries or some outliers. I do remember during those sessions 10 months ago, there was this one entry, I think it was entry of age. On the data set, there was a certain entry that has age around 980. And then I remember the facilitator asked us to tell her what's wrong with the data set. Do you see anything which is not okay? And then even though I couldn't figure out by then, it's amazing to know that she was trying to see if there are any invalid or outlier values. In that case, it was the age, a person age 900 years and 80, which we know is not possible. So in this session, we'll be covering one of the important steps in data management so as to ensure that our data set, our data frame is accurate, is consistent, and can be reproduced. And this slide is going to cement what I was just saying. So for instance, here we can see we have the points. All of these are numeric, but here we have a character entry 3. Here we have an empty cell. And then you also have an empty cell. It's just an exclamation mark, which may not be so helpful in analysis. Here we have another empty cell. And then again, here we have a couple of entries that are quite different from others. Okay, so I think we do this first. Sorry. Okay, so here we can see we have a police as one of the entries for occupation, but here we have a police officer is another entry for occupation. So even though these two may mean the same thing, during analysis, they'll be seem like two different observations. So we'll have observation for police, and then we'll have observation for police officers. The same is seen around here. We have hypertension, abbreviated as HTN, but we still have another entry here and here that is recorded as hypertension in a long form. Just like we have diabetes here, and then we have DM here, that is recorded in a short abbreviated form. So in this stage, what we are trying to do is try to ensure we have consistency in all these entries before we go to the next stage where we are going to do our analysis. Okay. So one of tools that we can use to try to ensure that our data set is consistent is the package called dplyr. And the package itself is usually a part of a big package that's called tidyverse. And from last session, I think we learned that package are things that help us to execute different functions or different manipulation on our data sets when we are using the R software. So I was trying to think of what analogy can we use when we try to think of what's a package. So I was thinking maybe we can try to view it this way. So think of a package as how our parents used to call us back then. So your parents want to maybe send you to a shop to take something there. And then he will call you, maybe Ludovic, just come here. And then after come there, he'll tell you, just go to the shop and fetch me this and this. So in that example, we can say that the packages are just like how we were used by our parents so that they can have their end goal, which maybe is cleaning the data or maybe visualize, etc. So in this instance, maybe the parent can be the software itself, and then the package will be a person who is called to go to the shop and do what they're tasked to do. So in this session, we are going to cover the dplyr package. As I've just said, is part of a big package called tidyverse that has other packages such as ggplot, such as stringer that we are going to learn in next section, such as ggplot that we are going to use during visualization session, and others such as tidyr, rubricate, etc. So what these packages actually do is it always helps us to make our data management a little bit faster, readable, and as you can see, it's easier because most of the things are just intuitive, just like how you would have done them if you are supposed to do them intuitively. And the package itself has more than 20 verbs. They are called verbs because you'll see that they offer different actions. So maybe I want to select a certain column. I'll just go to a verb called select. I want to filter, just go to a verb called filter, or maybe arrange, or maybe mutate, or maybe summarize, etc. So the concept of being called verbs is because most of these functions, all these functions are just actions. They are verbs. So in this section, we are going to cover some of the verbs. We'll cover select, which helps us to choose a specific column. So as you can see here, we have five columns. And then here we have, we've just selected this and this, and then we just end up with two columns. So we've just used the select verb function to just choose only two columns that we are interested with. Here, maybe we want to filter rows. Here we have 5 rows. We're just interested with the second, fourth, and fifth row. We can just use filter and just filter what we want. Maybe you want to arrange this observation, this rows based on certain maybe order. We can just use the arrange function, and then we can just do that. And maybe sometime we may just need to create a new column. Maybe we have a column of height, we have a column of weight, and then we want to calculate a BMI. We can just calculate BMI from weight and height. We can just use mutate to change, or maybe to create a new column, or maybe to change certain entries that are in the rows to what we want. And then lastly, we can just summarize different things that we want using the summarize function. But then as we go along, we learn that there are other verbs. We have join, we can rename our columns, we can see if there are duplicates, maybe in our data set using distinct. We can just use slice to select maybe certain rows alone, which can all be come in handy when we are doing different manipulation on our data. So, and this completes a very short introduction of what we are going to do today. So before I proceed, I wonder if there are any questions or maybe inputs, further explanations from other facilitators.
Nothing from me. I think this is a really good summary table, actually, just to show the most commonly used um, functions within dplyr. I will say personally, like mutate is my heavy workhorse function. I use mutate more than anything over here. But that's all I have to add.
Thank you.
Yeah, I think that's with the graphics on the side, that actually makes it clear as to how those functions operate. And I also second Ashna. I actually use mutate and summarize a lot. Sometimes to a point I actually think I misuse them, but yeah, they're really helpful function when it comes to manipulation of the data. Yeah, thank you, Dovik.
Okay. So if we don't have any other questions or maybe inputs, I think we can go ahead and go into practice on RStudio and try to see how these things works on that side. Yeah.
Nakota, it will be shared shortly via the chat so that you can be abreast with what Ludovic is doing. Thank you.
Okay. So I think after downloading that file, you just need to unzip it. And then after opening it, you just have to open this dplyr verbs participants R project file. And then after that, you'll just click on this, participants deploy verbs R&D, and then we can start from there. What we'll be covering in this practice session, we'll just have, actually we've gone through the introduction. We'll have a glimpse of the data set that we are going to use. And then these are a number of dplyr verbs that if time will be on our side, will be covered. If not, maybe we may just end up somewhere around here. But at least all this will be available in the Afredac platform. And then, as I just said on the introduction, whenever we get a raw data, or we usually get something like this. We have this many entries, this many observations that usually looks like this. But what we are trying to do as data analyst is just try to figure out how can we sort this into something that things that start to have senses, so we can group them based on different things, maybe if it's sex or whatever, and then we can rearrange them based on how we prefer, and then we can create some visualization to try to see what do we see from our data. And then finally, after creating this beautiful visualization, we usually need to create a story that can back up all the the findings of our data set. So if it's a research, or maybe if it's a policy brief, at the end of the day, you need to create a story that will make it easily understandable to those who will be using them. So what we'll be doing next is try to see how we can install this package in our RStudio, just in case you don't have it. And as it was pointed in a previous session, whenever we want to do anything on RStudio, we need to call that child and send him or her to the shop. So we need to call the packages, and then after calling them, we need to start doing what we want based on different functions that these packages can do. So normally, if you don't have the package itself, you need to first install it, and then you can load it with library. So to begin with, we can install the dplyr package as part of tidyverse, or we can just install it as a dplyr package alone. So normally it's usually installed as part of the meta package that we discussed earlier. That's called tidyverse. And we just do this by just writing this called installed on packages, and then just write the code. You just write the tidyverse, and then you just run that code, control. So yes, control enter. No. Okay, so I have the package, but you can also install it as part of the as a standalone package. So just like dplyr. Okay, so we can also install it by using this line, just control enter, and then it will run that line. And then later on after this, you need to do the needful by call that package before we ask it to do what we want. So I'll finish by call it. Yeah, and as we can see, the package is called. So after that, we can just go ahead and do whatever that we wanted to do. So have they been shared yet? I mean,
Yes, I see a phone shared.
Okay.
Yeah, I've actually tried accessing it, and you can actually download it. So I think Anakota and the team, the file has been shared. So now we can continue. And please confirm if you have any
Yeah.
problems with getting the file. Okay. Yeah, Ludovic, please go on.
Okay. So as I said it earlier, after downloading it, you need to unzip it and then open it through the dplyr verbs participant R project, this one. So you'll click that one and then it will open to something like this, what you're seeing around here. And then you'll come and click this one. So after clicking that, okay, so don't mind about whatever is written above here. You can just leave it for now. You can just come and click on this. So this will technically run everything that's above this chunk. And then after that, you can start by, you can write this, you can install the packages. So just complete this code. Complete that code, and that one. And then after that, you can just run. And then that should perfectly download and run the dplyr packages. Even though these same lines also do the same thing, but we can just start with this for now. So after that, we'll be importing our data set. And we do that by this code, by writing this code. So this code was complete. So we just come and run the chunk. So here, what we've just done is we've used this package, readxl, and then from it, we've just used the function called readxl, and then we've used another package called here, which helps us to create like a relative path. Okay. Anyway, you can just run this code for now. This will give us our data set. And then I think we'll have some other discussion on this package and why do we have to put it there? And actually, why did you have to share this file, even though there are other alternatives on how this can be done? So after running this code, we're supposed to get this data frame. And from here, we can see that our data frame was 1,500 observations. And we have 17 columns. So we have 17 columns starting from ID to the last column will be prevention management. So we have a column called ID, we have another column called age, we have gender, occupation, we have height, we have weight, etc. So below these column names, we see these things, CHR, we see these DBL, CHR, DBL. So this refers to the classes of these variables, the columns, the IDs, the ages, the gender, the occupation. And I think we Ms. Chioma passed us through the concept of classes of different variables. So this is a character. This is a double, also called numeric, and then integer, and then this is and then all these are just double. And then we can see here. Okay, these are all doubles, and then we have characters again. And then this LGL is logical, so we'll have a series maybe of yes or no, 0 or 1, and then all the rest are just characters. So this gives just an overview for our data set. We can just go ahead and try maybe to just have some other things, to just see some other things. So maybe you can just write view. Okay, so maybe you can just, so as you can see here, we've just have printed out a list of just the 10 top main rows with their column names. But if you want to see the whole data frame, you can just do that by so just write this code, so we just view. And then it opens like this. So we can just see the whole data set from the beginning to the end. So as we just said, okay. So here we can see that this the first page is going to just show us the 324 entries out of 100 and 500 entries, and the columns are still 17. And we can see all the columns from left to right. Okay, so we can just have maybe a summary, just an overview summary of the data set. So this gives us a summary of all the variables that are in this data frame. So the ID has 100 and 500 entries. The class is character. We have age here. So it gives us the minimum age in the data set. The maximum age in the data set is 84. And then we have the mean age is 42. And then we have median age is 43. And then for gender, it tells us the minimum gender is 1, which we know this is not correct because gender is either you are female or male or something like that. So at least it's not supposed to be, analyzed like this. So there must be something wrong with the class. So the class must be not appropriate. So let's go back to gender. Yeah. So gender here is recorded as double, which is not, it's not right. So it's double, which is not right. And then I think in the last session, Ms. Shoma also passed us on how you can change these classes from one class to another so that it can be easier for you to go on with what you want to do. Okay, so let's go back to this and then go directly to the dplyr verbs. So here we have a summary for every variable in our data frame. And then what's important about this little code, a very short code, is you can also see entries that have NAs. So in case you have NAs in the data set, you'll see it at the lowest row. So we have in these CD4s, we have 1,357 NAs. Here we have NAs, the same numbers, and then the others don't have NAs apart from this one. So we can also try, we are already trying to see if our data set is complete. So if we have variables that are not complete and we start taking note of this, so later on our analysis, we can make sure that either we drop these variables or we just need to do some other manipulation to ensure that the analysis that comes from these variables can be generalizable or can have insights that were intended. So after saying that, we'll just go direct to the select. As I said it earlier, we use the select function whenever we want to select a specific column. So I'll just show it in a little while here. So for instance, here we have 4 columns. And then for our analysis, we're just interested with just column A and C. We can just create a subset, a little the data frame out of this with only A and C. And we can do this by using the dplyr verb called select. And okay, so we'll just go direct to this. So for instance, let's say maybe in our data set, okay, this one. So we want maybe a column that only has age, maybe, and gender. So we can just come and complete this code. So we start with our data set, HIV data _ row, and then we write this, the percentage sign, and then greater than sign, and then percentage sign again, which we call pipe. I think it was also covered in last session. So we use this, the so-called pipe operator, to basically say that we take everything that's in this and push it to this second line. So everything that's in line 64 will be dropped down to line 65 with only an addition of what this select will tell it. So we take the old data frame, HIV data underscore row, and take it to line 65 and say we select only age and occupation. So, select age and occupation. So if I highlight this and run it, I'll just end up with 2 columns alone, age and occupation. So what I've basically done is what I was just showing you here. So I had 17 columns here, and then I've just selected only 2 that I'm interested with just select function, select verb. As you can see, it's so easy. It's just intuitive. I want age and occupation. I just need to put select before everything else, and then you get what you want. So this is one way of doing select. Sometimes you may find yourself that you need to select multiple columns. Say I want to select all columns from age to VL, viral load. And then based on what I've just said, it means I need to write age, I need to write gender, I need to write occupation, I need to write height, I need to write weight, I need to write HIV up to here, which can be painstaking. So what we can do instead, we can just use this the colon sign. So we can say HIV data row, and then we put our part there, we put select, and then after that we say we want everything from age, we put that colon. So I can say here, we can use colon to select a range of columns of interest. So basically what I want to do is to select everything from age to viral load. So I'll just put age, the column, and then I'll put the viral load. And then if I highlight this, I'll get something like this. So originally we had 17 columns. Here we only have 8 columns. And the 8 columns that we're having here are age 1, 2, 3, 4, 5, 6, 7, and 8. So it will select everything from age to viral load. So that's another way on which we can select. Now it will depend with, do you want to select everything that they are consecutive, the columns are coming after each other? Sometimes you may find yourself that maybe I want the gender column, I want the HIV column, and then after that, say, I want type of diagnosis column, and maybe prevention and management column. So the columns are not in series. You don't find the next after the other. So I may use something else. So we can also do select. We can use another function called this one to select certain columns. Okay, so that don't come sequentially. So we can say maybe HIV. So let's try here with a small data set. So HIV, say we want gender, so we can say select, and then C. So we can say I want gender, which is this one, and then I want HIV. I want HIV, which is this one. And then maybe after that, I want, there's a CD4, then I want viral load. So let's see. So by doing just that, I've just selected 3 columns that were not in series. So I just choose gender. So if you look at this, I had gender, then occupation, then height, then weight, then HIV. So after this, there are 3 columns, and then I could find HIV. So I can just write this code to just select specific columns that I want out of this data set. And from here, I just have gender, HIV, viral load, which were the 3 columns that I wanted. So this is another way on which we can use select to select the columns that we're interested with. But there are also some other functions. Sometimes we may look at our data set and find that we have common words that are in certain variables. For instance, here we have date of sample collection. So we have a column that is a word date here. We have another column that is a word date here. So we can just choose by just this thing. So we can just say maybe select everything that contains the word date. So we have another helper function that can help us with that. So these helper functions include things like, okay, so we can say, for instance, HIV, and then select, and then, so select anything that contains the word, let's say, anything that contains the word date. So we can see here we're supposed to have 2 columns, date of sample collection, and the other one, date of diagnosis. So if we run this, why? So we're supposed to have these quotation marks before the word date. So here I've just selected all the columns that contains the word date. And here we can see we have the date of sample collection, and we also have the date of diagnosis, the 2 columns that have the word date. So that's another way on which we can use the select function. But there are actually other ways that we can use it. So here we've just covered, okay. So we've just covered this. We've just used the colon. We've just used the C helper function, and then we've just used the contains function. We can also use this function, the start with, selecting all the columns that start with certain word, or maybe end with. So I can just copy this and see how we can use them. So we can say using helper functions. So here we can say, okay, so here we can say maybe, let's select everything that ends with certain word. So let's see how many columns have, okay, so here we have a column that has a date of diagnosis. We have this word, at least agnosis, gnosis. Here we have gnosis also. Okay, but we can also have this one as management, that one as management. So we can say maybe let's select all the columns that ends with the word maybe meant, and see what we get. So HIV data, and then we send that to select. And then we say select end. We select everything that ends with management. So everything that ends with that word. So by doing that, we've just selected the columns that have type of case management, have that word. We have that word in that gement, and here we have the gement. So this shows you there are different ways on which we can select the columns that we're interested with. And then we can also do that with this helper function, selecting everything that ends with. So HIV, data, select, and then as usual, end with, and then, okay, start with. We already have this one, so start with. And then see, what can we say here? So for instance, we can choose everything that starts with the word type. So we will be selecting these columns, type of diagnosis and type of case management. So we say, so type. So if you run this, we also get the columns that have these words type of diagnosis, and type of management. So this is a summary on how we can use select verb, on how we can choose different variables or maybe the columns that we're interested with. We can do it by just name them. We can do it by just use the column to select the range for the columns that are consecutive, that they come in series. And then we can just use the chelper function just for columns that don't come in series, but to just pick one here, pick another one there, pick the last one at the end of the data frame. But also we can sometimes take advantage of the words of the variables that have similar names, whether the names are ending the similar way, or maybe they start in a similar way, or maybe they contain a certain phrase that's common for those data set. And then we can use the contains, the select, as well as the end with and the start with. So sometimes, so this concludes at least the easier parts on how you can use the select function. Sometimes we may say okay, so some data sets, for instance, some demographic health surveys data sets that are usually done in developing countries have many variables. For instance, they have as many as 500 maybe and 50 variables. So you have 550 columns. You can try to imagine if you were to put that in an Excel spreadsheet, how difficult will it be for you to just pass from one column to another and try to have a glimpse of what you are really interested with. So in those data sets, the functions like the select function of the dplyr packages, the dplyr package, come in handy because you can just select only the columns that you're interested with. So for instance, let's assume this is the data set from maybe the DHS, the demographic survey that has 450 columns. So out of this, maybe we just want maybe only 8 columns. So I'll just use the code below, which will give us 8 columns. So just want only these 8 columns out of these 450 columns. So normally we'll need to create a little subset by using this sign. So maybe you can say HIV data row, and then let's say subset. So from here, we'll just take this huge data frame that has many variables. We know ours had only 17, but let's assume it had 550. And then out of that, we just select only those that we're interested with this. And then here, after this, we'll just end up with, if we run this, by doing that, we'll just create another, remember you have to come to the environment, and you can see that we've just created another data set called HIV row subset that only, if we come here, only has 8 columns that we're interested with. And this is one of the reasons why it's very important to learn R, because let's assume we have that huge data set and we have to work on it on Excel. It will be very difficult to pass from one column to another, to select what you want, especially if they are not in series. You have to choose one here, another one there, and then the other one at the end. So we can just take advantage of that with all these columns, with all these functions, whether we use this one or maybe if we select what we want, or maybe the one that contains something. Because for instance, in that data set that I was telling you about, the demographic health survey, so you'll find that you have variables maybe that talks about maybe reproductive health. You have variables maybe that speaks of maybe wealth index. So you can just come and write, I'm only interested with variables that talks about maybe wealth index. So maybe wealth. And by just writing that, you have all the columns that talks about wealth. And then after doing that, you can always create a subset. So you create a little, so you create a subset and say maybe based on that, you can just call it maybe British web. And then when you find yourself, you can just do the subsequent analysis using this small data frame while preserving the original file and all consecutive files that were created after that. So this is the simplest way to explain how the select function can be useful in whatever we are doing. So do you have any questions on that? Hello?
Yes, we can hear you, Ludovic.
Yes, so I think Ludovic is just a comment. So it means that it is always advisable that when you're working with a particular data set, if you want to do some manipulation, it's just good that you maintain the original one, which you can access at any time, but manipulate a newly created data set from the way that you've shown. Yes, and from practice, that is a very important step, because you may find that you are the custodian of a data set for maybe DHIS, and you just mess up with the original one. So it's really an important step, so that you make sure that you always have the original data set with you, and manipulate a newly created one. Yeah, thank you.
Thank you so much for that input. I think that's a very important concept to keep in mind. Always maintain the original data set. And this is one of the ways on which R become very easier to work with, because we can see here, we can just maintain this and create all the subset with just little codes. And if you are trying to imagine how you could have done this in an Excel, probably you have to create one file, then another file, rename it, and then start working on the columns and the rows, and then save it. If it happens, maybe you want to create another one, you'll have to do it again. Or maybe create a series of spreadsheets, which are also difficult to manage. But here with a very simple code, you can just do all of that. And that's why we are advocating for it. Okay. Ashna, do you have any addition on that?
I just seconded Duncan's comment. Yeah, I mean, maintaining the original data set is really important. And then also just to quickly mention, the starts with function and select is actually very useful in standardized data sets like the demographic health survey or other big data sets, because what you'll notice in a lot of those is that, for example, if they're tracking symptoms, a lot of the symptom variables will be noted as symptom underscore coughing, symptom underscore high BP, or things like that. So then it's quite useful to be able to say select everything that starts with symptoms, and then suddenly you have your own symptoms data set. So it's very handy in practice.
So maybe, and then the last thing, maybe you may find yourself that, so maybe after working with this data set, okay, this one, let's take this and put it here and see how we can use, so we can also use this exclamation mark to negate whatever is written in the codes. So for instance, let's assume that we are no longer interested with these variables, but we are interested with all other variables in the data set, with the exception of these 8 variables. So practically, we'll be interested with all other variables that are not actually mentioned here. So we can do that by, okay, I've just copied that one. Okay, so we can do that by just saying, here we'll be selecting everything from age to viral load. By just adding the exclamation mark at the start of this, we'll be selecting everything that's not from age to viral load. As simple as that. So let's call this subset 2. And by running this, if you are okay, so just scroll it. Subset 2, if you run it. So here we'll see we have everything that's not age up to viral load. So if we are to open this data set, subset, so we'll have C in subset 1, we have age, gender, occupation, height, and everything. And then subset 2, we have everything that's not from those which have been mentioned in the previous subset. So that's another way on which you can select columns that you think maybe I want everything with the exception of this. So you can just write everything as Ashna just explained. Maybe you can say I want everything with the exception of anything that contains diagnosis, anything that contains maybe reproductive health, anything that contains this. And then you'll have all other columns, which will be easier instead of picking them one by one, or maybe using other functions. But as we've just noted at the very beginning of this session, when they said, our two mentors said that they are very much used with mutate, sometimes you may find that you're just comfortable with using this and actually don't really need to use the other one. But it comes with experience and what you think is preferable to you and things like that. So that concludes our short journey on select functions. We'll be seeing more of this as we go along. And then we can come down to this other function that's called rename function. So with rename, we can use rename to rename our columns. So if you are using maybe an Excel spreadsheet, we would have easily going to the top row and select the column that we want to rename and then write whatever that we want. We can easily do that in R. So for instance, we can say, this is our data set, HIV data. And then out of this, we do the select that we've just learned. And then we are going to select ID, hospital of diagnosis. We are going to select HIV, and then we are going to select gender, and then we are going to select age. So we can say, okay, maybe let's rename these columns to the words that we think will be more sensible to us, that are more intuitive to us. For instance, if you look at hospital of diagnosis in the original data set, when we say hospital of diagnosis, what their entries are Mombasa Mission Hospital, Nakuru. So actually, these are just hospital names. So what if we just call it hospital rather than call it hospital of diagnosis? Because we don't have any other variables that mention hospitals. So you can just call it hospital. So we need to change it from hospital of diagnosis to hospital. How we can do that, we can use the rename function, in which, how you do it, you use the rename function, and then you write the names that you want. Okay, so here, you use the name function, you just write the name that you want, and then you write the name that was there previously. So for instance, in this data set, the previous name was species, and then they wrote it to enemies. So we can use the function rename, and then we write enemies, and then equals to the previous name. So we start with the new name, then the previous name, and then that will change this column name from species to enemies right away. So here we can say rename, we write the name that we want, hospital, and then we write the previous name that was there, hospital of diagnosis. And then if we are to write this, we are supposed to have a data set that contains a word hospital as a column name rather than hospital of diagnosis. And that's what we can see here. So if you run this, we have hospital here, while previously our data frame contained hospital of diagnosis. So with rename function, we can just do it like that. So maybe we want to change gender. So from maybe gender, maybe we want to write it as sex. So we can just put a comma there, type enter, and then we can say sex equals to the previous variable name, gender. And if we run that, we should have a variable that this one is that is a name sex from the previous gender that was written before. We can do that again for HIV, okay, so maybe, so maybe HIV wanted to be in capital letter, HIV. So from the previous one, HIV. And then if we run that, we have hospital, HIV, and sex. All the variables have been changed from what we've just written. Okay, so we'll do one more time with age. So we can say age, and then we write the age. And if we should run that, we have hospital, HIV, sex, and age with different column names from the names that were original on our data frame. And as usual, whenever we are going to change anything in our data set, we have to always remember to assign it to a new data set. which will make it easier for us to retrace the steps just in case there's any bug, and we can work on that. So we're going to just create another. So we've just created another subset that contains only ID, hospital, HIV, which is capitalized, sex instead of gender, and age with capital A rather than the small a that was previously in our data set. So this is how we can rename the columns. You can also do this with the select function, but I actually prefer this because I think it's more easy to understand. So you can just do this by okay, so we can just open all of these. So we call this, like I said before. So we just write the same code. HIV data subset 4, we have just assigned it as a new column. And then we are going to select, the columns that we're interested with, but we are going to start with so we are going to select the columns that we are interested with. Hospital, then we are interested with sex. Okay, so maybe let's call this maybe so that we can differentiate it. Maybe sex, participant, and then maybe this HIV, maybe status, and then maybe this page participant, and then maybe this hospital name. Okay, so we are going to select the same variables: hospital, diagnosis, gender, HIV, and age, but we are going to start it as if you are writing the rename code. So start with the hospital name, which is a new variable name, and then we write the previous name, and then the sex part, and then we write the previous name, and then if you run this code, it will create a new data set called HIV row subset 4, which when we look at it, you will see we have a different column name: sex part, HIV status, age part, and hospital names, which are quite different from what we had earlier. To remember, which had HIV capitalized, sex with a capital letter, and age. So as we can see, we can also rename our function with select or with the rename function. I personally prefer to use this. But I think this also can come in handy because you can just use select and rename at the same time, and then you just do everything that we are doing. Yeah. So any addition, Duncan and Ashna, on this before we go ahead?
None for me, actually. This was very, very concise and very clear.
Thank you. So after that, we can go to filter. So with filter, what we actually use it for, we use a filter to just choose the columns that we're interested in. Okay, so I don't have a picture for that. So we just use it to select the rows that we're interested with. So you use select for columns, we use filters for row. So it will be helpful to for us to choose whatever that we want in that row. So usually in a column, you will find that one column have different categories of observations that are usually on the rows. So maybe we can, let's see. So maybe let's look at, okay. So maybe we can look at the occupation. And from here, we can say from occupation, we have those who were doctors, we have those who were drivers, and then we have those who were businessmen, we have the nurses, etc. So let's assume that we are all interested with the doctors, or maybe we're all interested with police. How do we filter that? So actually what we would have done will be to filter. What are we filtering? We are filtering the occupation column. And out of this column, what we want to filter is all those who are, let's say maybe they are doctors. So So doctor. Okay. Yeah, I have. I had 0 rows, and I was wondering why. It's because of the S. So if we say doctor, yeah. So this filtering will help us filter everyone who mentioned the occupation as doctor. So everything have been filtered based on these rows that have doctors. So everything else have just come along, but we've done everything based on this. So as we can see, the whole data set has only people who are doctors in the occupation. So maybe if you want maybe a nurse, say your nurse. And then if we do, this column have to change from doctor to nurse. So if we do that, have nurses. Okay, so we do one more time with other variables. So okay, so let's say we want to use commodity. And then maybe we want to filter everyone who had hypertension. So if I run that, everything has been filtered based on this column and these rows. Everyone with hypertension has been filtered. So we can say maybe among those with hypertension, which occupation contributed more in this data set. So by just doing the filtering, we can just filter them to just have only those who had hypertension, and then we can just try to see which occupation maybe was more affected, or maybe which gender, or maybe which age, and things like that. So that's how we can use the filter. But then again, okay. So sometimes we may find that we have to use this, which are called relational operators, while filtering. For instance, maybe in a data frame, we may need maybe doctors, maybe with age, maybe greater than 40, or maybe with age, maybe less or equal than 40. So you'll find that now and then we'll be using this signs, less than, less or equal, greater than, greater or equal, all this, which in this instance will be equal, or maybe this, which is not equal, or maybe this, which means that A is an element in B. So how does this work? Let's see. So suppose say maybe so maybe let's say age. Here. And say maybe you want to filter in your data set all those. Let's filter all with age, let's say more than 35. So we come to filter, we just write age, and then rather than this sign, we can just write 35. And just by writing this code, we've just filtered everyone who had age above 45. So all the entries here will be of people who have age above 45. We can say maybe age below 45, 35. So here we have, okay, so, okay. So here we have 865 entries. So let's see how many entries we have here. So here we have 621 observations. So here, everyone who is enlisted here had age below 35 by the from this data set. So we see 26, 21, 24, 32, etc. While if we look at this, what we're seeing is 49, 83, 76, etc. So we use filter basically to filter anything that we want within these columns based on what we are interested in. So sometimes we may find ourselves maybe we have more than one condition. For instance, let's say you want to filter age above 35, but at the same time, we want those people to be maybe students. So we have two conditions at the same time. So copy this. Okay. Age about 35. And then for end, we can write end. And then students is in occupation. So we write occupation. And then occupation equals student. So if you run this, what it have done, it will be to, it will have select everyone who had aged above 35 and whose occupation were students. Astonishingly, we have students who were 80 years old, 74 years old. This must be our students.
Yeah. And
Yeah. So, yeah. Go ahead, Duncan.
yeah, I think those are those who attend the evening classes. Okay.
Okay. Okay.
Yeah, but
So,
just yeah,
go ahead.
it's okay.
So, yeah. So that's one how we can combine different conditions. So maybe what if we want everyone who had age of 35 or more than 35 years, but or whose occupation was a student. So anyone who had satisfied any of the two conditions, maybe he has age more than 35 or the occupation of student. So if the occupation is student, he will be in our data set, or if the age is more than 35, he will be in our data set. So we can take the same code. So this will use if, so this is for exclusive condition. So we want what we have filtered to meet both two conditions. So it has to have this one and the other one. So if it should have any of the conditions, we can just, rather than write this, we can just write this. How do we call this?
I don't actually know if it has a name, just the or operator, I guess.
Oh, so you can just write the O operator. So from here you can see here it will have everyone who had age of 35 or above, and and anyone whose occupation or anyone whose occupation was student. And we can demonstrate this by looking at this occupation column. We can see we have doctors, we have policemen, we have students, we have farmers, which actually some of them don't meet this condition because we only wanted the student, but they've been included in this data set because they had the age of more than 35. So they've been included because they satisfied this first condition, even though they not necessarily satisfied the second condition. Some of them satisfied both conditions, but some of them didn't satisfy both conditions, but at least they satisfied one, and they've been included in this data set. So this is how we can use filter in the operations.
Ludovic,
Yeah.
that line 151.
Yes.
Can we also select the students who are age 35? Sorry, can we filter the students who are age 35 and above,
Yeah.
and those who are students and also who are female?
Okay. Okay. 35 and above. Occupation who are students, and
Students and also female.
3 end is right.
Mhm.
So female, that will be, so I show female is maybe 1, right? So here we have, in gender, we have 1 and 2. So maybe female 1 or, let's say 1. So let's say, what if we write this? Gender, uh, gender, and then so let's see. This one. So, so we've just written this. So we've just filtered those who are aged 35 or above, and occupation was student, and their gender was one, which let's assume one is female. And then we only have those who satisfy all those conditions are only 29 people.
Yeah, okay, great.
Yeah. So maybe you can say, okay, we can add on that. We can say maybe those who are 35 and above, occupation is student, but let's say all gender equals to 1. So this will select all females in this data set. Anyone who missed this, either is a female in this data set or have this this condition. They're aged above 35, so you select all females because of this, and then they'll select everyone who have age of 35 or above, and the person is student. So we have the gender. Let's see if we find number 2 in this. Yeah, for number 2. So all 1 have been selected because we have condition that necessitate that we have females in this data set that we are creating. But then we had 2 other conditions, exclusive conditions, that needs all people who are age 35 or above and whose occupations are students. So we have come and found that we have a male student who is aged more than 35 years around here, which was not supposed to be there if this condition was not all. If it was end, we'll only have female participants in this new data set that we have created. So are there any other inputs, Duncan and Dashna?
I've just added one in the chat, just to say that you can do multiple text-based filters also using this operator, the %in% operator.
Yeah.
So for example, if you wanted everyone who's a policeman or a student, you can say occupation in police or student, and then filter it that way. There's another variation. We may have to redo the quotation marks.
Okay.
I think there's a quotation mark missing after the police.
Yes.
Yeah.
Yeah.
Yes.
So this is what Ashna was saying. So we can also use the this one, this sign, percentage in percentage, which shows that we want to filter in the in this column. We want to filter rows in the occupation column, but specifically within this column, we want to filter the following elements: police, those who are the whose occupation was police, and those whose occupation was a student. So this can help us to filter multiple conditions within the same column, right?
Correct. Yeah.
So, and we can see here we have our entries the data set will only have policemen and students. So we have policemen and students, policemen and students. So we can just do this the same by saying maybe let's add business. So by doing this, we're supposed to have now. So we have business, and then we have police, we have students. So at least here we can see we have selected at least 3 elements within the occupational variable. So this is how we can use filter in different ways. So we had a little practice here. So this one is done. Okay, so what's the total number of clients who had confirmatory diagnosis in this data frame? So confirmatory diagnosis. So we have this variable called type of diagnosis, and then the entries within, we have confirmatory, we have initial, and then we have follow-up. So we want to filter only those who had confirmatory diagnosis. So we start just like how we did in the previous examples. So HIV data frame, and then we want to filter. We say we want to filter all those who had confirmatory diagnosis. So type of diagnosis, we want it to be confirmatory. Type of diagnosis. So we see type of diagnosis, we only have entries that are confirmatory. So all observation are for those who had confirmatory diagnosis. And this wanted to know the total number of clients who had confirmatory diagnosis. You can see it by looking at these observations here, but you can also see yeah. So we can write just, so after filtering this, we can just write this function count, and then it gives us the count of all participants who had confirmatory diagnosis is 250. If maybe we're interested with those who had follow-up or maybe initial, you can just say maybe copy this. And then maybe do initial. Or if you run that code, those who had initial type of diagnosis were 982 and 8. So this 282 had confirmatory, and the other one had initial diagnosis. So here we are starting at already trying to use, okay, so different functions for on top of the dplyr that we've been, which we've been working on. So far we've covered select, we have covered rename, and then we've just finished covering the filter function. Okay, so we're supposed to go to mutate now. Should we continue or?
Yeah, I think Ludovic, we're at top of the hour.
Yeah.
So I think whatever has not been covered, we can post it on our e-learning platform, and then come next week, that is the R for Fun Club, we can try to brush over what has not been covered during that session. So I urge all the participants to actually go through what Ludovic has covered and what he has not covered. Then whatever next week, that is for our fun club, we can meet and have an informal discussion of all the concepts there. But otherwise, Ludovic, I take this opportunity to thank you so much for that wonderful session on dplyr and usage of functions and verbs in dplyr. It was really interesting. And unfortunately, you could not cover the other elements, but let's try and cover most of that during our R for Fun Club next week. And it was really interesting, and we hope that we'll be seeing more of you, Ludovic, in the coming sessions. And that was really interesting. Otherwise, we thank you all for attending. Please pass the message to your colleagues who are not able to attend. They can always get this material on our e-learning platform. And also, if they're interested, they can join next week. And the other session number 3, which will be covered by Ashna. Otherwise, we thank you, Ludovic, so much for that. And let me hand it over to Virginia to wind up the meeting for us. Thank you.
Yeah, thank you, Duncan, and thank you, Professor Ludovic. It was really interesting. It has been a long time I interacted with R. I was mainly interacting with Python recently, and you have really challenged me a lot. I really enjoyed every part of the session. So, and I see some familiar people who have joined us with us today. So this is just like the continuity of the session that we have started over the past 2 weeks. And today we are doing the data cleaning by using the dplyr. So I've shared the link within our chat within afredac.net. So it's where most of the materials that Ludovic and other facilitators that they have been using over the last 2 weeks, that's where they are within the e-learning pages that if we will just put like a bit of the description on where we are going to find these contents, because there will be some quizzes so that by next week, same day, same time, Ludovic, Duncan and Ashna, and they'll be taking us through those quizzes. And maybe during the session, you have something that you can contribute. Please always feel free to raise your hand, because we need this session to be a bit of interactive. So thank you, all of you. I really appreciate for your time. To our facilitators, Ludovic, Duncan, and Ashners, I really appreciate it. And to all of you who really took time to join our session today, thank you very much. And welcome again next week, same time, same day.